Hey, one last improvement for this blockchain application, and let's get to it. We're going to add support for a paginated exploration of the blockchain data. This will help the front end significantly, since it won't try and render a huge list of blocks. Rather, the user will be able to explore the blockchain in segments. Now, there are two bits of information that we need to expose to the front end to support this behavior. One is the current length of the blocks in the chain, and two, the paginated endpoint itself. So in the main index.js file of the project, we're going to start by exposing the blockchain length. So this means we're going to have a new app.getRequest for API/blocks/length. Let's place this after the existing /blocks request. So that way it's nicely organized. So API/blocks/length. Okay, cool. Then we have our callback function with the rec and res parameter. Nice, as long as I can type it. There we go. The reason we want the length is so that the front end can understand how many segments there are in the paginated endpoint. Otherwise, it will be doing guessing work if the pages of blocks goes from 1 to 10, 1 to 100, or up to 500, etc. The length helps the front end know this limit. To expose the blockchain.length, we can run res.json. We'll input blockchain.chain, and then in addition, we'll add the .length. All right, cool. Now we have the paginated endpoint to create. This paginated endpoint will allow the user to specify a number directly in the URL to grab a specific segment of the blocks. This is still going to be a GET request, but to allow the user to pass in data, in other words, what ID or what number of blocks that they want to get for the group, we can take advantage of what is called a query parameter, which again is a part of the URL itself. So it's like a dynamic variable found by parsing the URL. We're going to make a GET request for /API/blocks, but then this time it's going to have this dynamic ID section marked by a colon. So make sure there is :ID. Okay, then we have the rec and res parameter for this guy as well. The query parameter is set within the request object this time. So it's something that the requester is passing as a parameter. And we grab that ID and express through request.params. Cool. And then our overall approach will be to paginate in sections of 5 through the blockchain.chain. Based on the pass-in ID, we'll send the requester 5 relevant blocks from the chain. For example, if the param is 1, we're going to send the most recent 5 blocks. If the param is 2, we'll send blocks from 5 to 10. If 3, 11 to 15, and so on and so forth, until we get to the remaining blocks with a last ID, whether that's 5 last blocks or just 1 last block. To begin, we'll need to run calculations based on the current blockchain.length. So let's grab the length from the blockchain.chain. There's no reason there needs to be a new line. Cool. With the length of the chain, as well as the requested paginated ID, we can give the requester a group of 5 blocks from the chain. Ideally, we want the endpoint to go from the recent blocks to the oldest blocks. However, the blockchain is currently organized from oldest, the genesis block, first, to the newest block last. Therefore, we're going to make a copy of the blockchain array that is reversed. And let's set it to a constant called blocks reversed. So this is the result of calling blockchain.chain.reverse. All right. Now, there's one gotcha with the current implementation. The reverse method actually mutates the original array that it runs on. Now, we don't want the original blockchain to be reversed and affected. We only want a copy to be reversed. However, we can use a copy using the .slice method, and usually slice is used to get a section of an array. But in this case, if you don't provide any parameters, it makes a complete copy of the original array. All right, cool. We're almost there. The final part is responding with a section of the blockchain. To do this, we can take advantage of the slice method again. We're going to return a slice of the reverse blocks now based on a calculated start index and a calculated end index. Passing back 1 as a paginated ID should get the most recent 5 blocks. So on the reverse blockchain array, that would be indexes 0 to 5. Therefore, as our start index that we calculate, this is going to be the ID minus 1 times 5. So, for example, if you pass back paginated ID, the start index, or rather, if you pass back the paginated ID as 1, the start index is going to be 1 minus 1, 0 times 5. So the start index is 0, which is the first block. If you pass back 2, 2 minus 1 is 1 times 5. So the first section of blocks that we're getting at the index from is 5. We're going to do the same thing from the end index, except this time we don't have to subtract minus 1. We can immediately do ID times 5. So the end index, if the paginated ID is 1 times 5. Therefore, our start to end is 0 to 5. If you pass back 3, for example, 3 minus 1, 2 times 5 is 10 as the start, and then 15 will be the end. So we're getting blocks 10 to 15. Cool. That is how the overall logic is going to work. There is one catch though. What if either the start index or the end index is actually greater than the length of the chain? Well, we can't make a slice of the blockchain past its limit. Therefore, let's set these to either their existing value if they're less than the blockchain length, or the length itself if they're not less than the blockchain length. So start index equals, well, let's check. Is start index less than the length? Well, then it's okay to make this the start index. Otherwise, we're going to set start index to the length. We should do the same logic for the end index. So if the end index is less than the length, then it's quite all right to set the index to itself. Otherwise, it should be the length of the blockchain. Cool. Now we're assigning values to a constant declaration. So we should make these let variables so that way the start index and the end index can be dynamic. All right, nice. Finally, we can return an array, or rather a sliced array from the block's reversed array. Let's call slice, and we're going from the start index to the end index in this slice. All right, very cool. So this should take care of a new paginated endpoint. Go ahead and fire up the application in dev mode if you haven't already. And on the command line, you likely have it going and should be listening at localhost 3000, and Nodemon should have picked up the changes, which means in the browser now we can test out these new changes. At localhost 3000, we want to visit API/blocks/length. And the length of the blocks is currently 11. Cool. So how about API/blocks/1? Well, we get 5 blocks. Cool. Look at the timestamp, and you'll notice that as we change from 1 to 2, it's indeed a different section of blocks. If you go to 3, this is the most telling part. There's only the final remaining block, which is the Genesis block in the application. All right. Now, there's only 11 blocks in the chain, which isn't much when it comes to exploring pagination. There's only 3 pages. Let's beef up the isDevelopment seeding data to go all the way to 20 blocks. So let's change this to a for loop that goes up to 20. And with a save of this, we should find a lot more blocks in the application. So the third page now, well, as it's still currently loading and generating all that block data, but the third page now should have a full page of blocks. Likewise, if you go to /4, there's a full page, and now /5 is the one that only has the Genesis block. Awesome. Next up, let's update our front end to utilize this new paginated endpoint to allow the user to explore the blocks in a much more scalable way.